All right, let's continue here with example 3. It says, homeowner wants to plant a border of shrubs around her yard that is in the shape of a right triangle. She knows that the length of the shortest side of the yard is 12 feet and the length of the longest side is 20 feet. How long will the border be? So we've got a yard that's in the shape of a right triangle, as odd as that may be. And what they've told us here is that the shortest side is 12 and the longest side is 20, and they want to know how long the border will be. So that means, of course, we have to find the third side in order to calculate that. Now, since they're talking about right triangles, we know that this side here has to be the longest side. And either one of these can be the shortest side. Now, how did we know that? Well, let's think about it. We've got this thing called the Pythagorean theorem. And the Pythagorean theorem says to us that in a right triangle, the hypotenuse is the longest side. Right? The hypotenuse is the longest side because it's always the sum of the lengths of the other two sides squared. Which means if I take this length and square it, and take this length and square it, and add them up, it's going to be equal to this side squared. Right? That forces us to use this side here as 20. And if you've forgotten, this side then is called the hypotenuse. And it's the hypotenuse because it's across from the right angle. And if that doesn't fly with you, then let's say it a different way. It's the side that doesn't make the right angle. Clearly these two sides that I'm motioning with are making that L shape my right angle. The other side is always the hypotenuse. So this involves us now invoking that Pythagorean theorem, Pythagorean formula here to find the missing side before I can find the perimeter. And that's what they're talking about in the first line of work here. A squared plus B squared equals C squared. Hopefully you remember that. We've touched on that before. The expectation is you remember it. A squared plus B squared equals C squared. C is that hypotenuse. And A and B are these two sides. But because of the commutative property, it really doesn't matter which one we call which. So let's go ahead and call this A and call this side B. And now we'll have to dump our numbers into that formula to find B, so then we can find our perimeter, which is our answer. So if I change A into 12 and C into 20, which is what you see right here, and then I'm going to do a little bit of simplifying. 12 squared is 144, 20 squared is 400. So I've got 144 plus B squared equals 400. Now, don't let that bother you that says B squared. Right? If it said B, you would know exactly what to do. Variables on the left, loads of numbers on the right. You'd subtract 144 all the way across, and you'd end up with B squared equals 256. Problem is that that side of the triangle doesn't say B squared. It just says B. So if it just says B, what I have to do now is go ahead and take the square root, because that's how I'm going to undo square and get back to just B by taking the square root. When I take the square root of 256, that's what they're showing you right here, that's 16. Remember, 16 times 16 is 256. So B is 16. Now that's not the answer to my question though. That's just how long this missing side of the triangle is. What they're doing here in the last line of work is showing you finding the perimeter, because that's what the question is about. She wants to know how much border she's going to need here to do this. So we're going to do 12 plus 16 plus 20, which is 48. So the border is 48 feet long. Okay, let's take a look at question 4. They're asking us to graph and find the area of the figure with the vertices negative 2, 2, 4, 2, and 0, 5. So they've given us coordinates here. Remember, coordinates are always written as x, comma, y. The first number represents something on the x-axis. That's the one that goes left to right. The second number represents something on the y-axis. That's the one that goes up, down. So as far as my x-axis point, negative 2, 2. So that means from the origin, I'm going to go left to negative 2, and up to 2 and put a dot, which is what you see right there. 4, 2 means from the origin I'm going to go right to 4 and up to 2 and put a dot. And 0, 5 means I'm not going to go right or left, I'm just going to go up 5 and put a dot. And I'm going to connect those dots, and of course, because there's only 3 corners, that means this had to be a triangle. Alright, now let's talk about finding the area of a triangle here. We know how to find the perimeter, that's not a question for us. Alright, but we do want to make sure we know how to find the area. You pick one of the sides of the triangle to call the base. And you can pick any side you want to work with, it doesn't really matter. I want to work with this bottom piece here, and I'll show you why in a minute. So that side is 1, 2, 3, 4, 5, 6 units long. So the base here is going to equal 6. And the other thing that's involved in finding the area of a triangle is the height. The height is required to make a right angle with the base, and it's going to go directly across from it to some other part of the triangle in general. So in this one, if I make a right angle with it, the easiest place to make a right angle with it would be right here, because then I'm going to go right up to this corner. It does not necessarily have to go to the corner, but it should go to the point furthest away, really. And I'll show you another example of this in a minute, because that can get a little tricky. That is clearly the point that's furthest away from this base, so that's where it's going to go to. Well, that's a distance of 3 there, so the height is 3. And those are the 2 components you need to find the area, because then it would be essential to know the formula. Well, the formula can be given to you a couple different ways. As you can see on screen here, it's a half times the base times the height. I can also say the base times the height divided by 2. Either way, both of those say the same thing. They say the same thing I need them to say. So I take my base and my height, 3 and 6, which is 18, and then chop that in half or divide by 2, whatever you want to say, and that's going to give me an area of 9. And since they didn't give me any units here, we're going to say it's 9 units squared. So then the question is, well, what if they give me some wacky type of triangle? And I assure you they will give you some type of wacky triangle. Alright, and that wacky triangle might look something a little bit like this. Now, this is not necessarily the worst triangle, but it does make it sometimes hard to find the area. Because what the book will do is they're actually going to draw a dashed line off one of the sides like that. And you're saying, well, why are they doing that? Well, I'll explain. If we call this side the base, which is what they're going for here, all right, the height to the point furthest away would be this point here. But remember, the height has to make a right angle with this guy. So in order to be the height to go from here to here, all right, to make a right angle, that would be impossible. But the trick is that the height doesn't really have to be inside the triangle. It's just a measured distance. It's not actually part of the shape. So when they do this little dashed line thing, what they're implying here is they want you to make another little dashed line like that that goes from this point to this point and makes that right angle and is thus your height. And that's something you want to look out for. Of course, the other way to do this one would be something like this. But of course, if they don't give you this distance or this length, you can't use that side as the base and you'd be in trouble. Okay, so let's finish this off with the check it out example here. They're asking us to find the perimeter of the figure. So they're asking us to add up all the sides there. So we're doing 9 plus 6 plus 11 in the triangle, which is 26. And that's going to be 26 units all done. 9 plus 6 plus 11 is 26. And that's our perimeter.